Hello everyone, welcome to my channel. So in this video we are gonna see pair plots. So up until the previous video we have seen the 1D analysis, 2D analysis and the 3D analysis of iris dataset, and in all the three cases we plotted some graphs. But suppose if we have features more than that, and in the case of iris dataset we do have more than 3 features, we have 4 features, then we can't create a 4D graph, and even if we do create, we will not be able to perceive it, okay, because humans can't understand anything more than 3D. Okay, so for that what we do is we use pair plots. Okay, so what pair plot does is it takes a pair of all the features that you have and plot different graphs for each pair. Okay, so let's see how that is done. Okay, so first I'll set the style. Okay, so sns dot set style, and that is gonna be white grid. Then sns dot pair plot. Okay, then the data set, then the hue. Okay, as we have seen in the case of 2D analysis, hue is the property on which the color changes. Okay, so we have the hue as variety, then size is 3, then we are gonna add legend. Okay, and then we are simply gonna show it, plt dot show. Okay, so over here we have our plot. Okay, so now let's move to the notebook and discuss about these. Okay, so this is the output of pair plots. Okay, so what pair plot does is it takes all the possible pairs from the list of features and plots their graph. Okay, so over here you can see that you will be able to find the graph for any two features. You can choose randomly from the list. So the list over here is petal length, petal width, sepal length, sepal width. Okay, now you can randomly choose any two features from it and you will be able to find a graph for those two features over here. Okay, so that is the beauty of pair plots. It will give you all the possible plots by taking two features from the list of features. Okay, so now let's understand what this graph says. Okay, so first of all, the diagonal elements are called histogram. Okay, so we will study about histogram little bit later. Okay, this is petal width. Okay, so we will study about histogram little bit later. Okay, now after that let's look at the scatter plots. Okay, so to count the number of scatter plots there is a simple formula called nc2, where n is the number of features. So in case of iris dataset n is 4, so the number of plot becomes nc2, which is 12, and if you count we have 12 over here. So 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, so we have 12 plots and 12 plots were possible. Okay, so this was the general idea of pair plots. Now let's draw conclusions from it. So one thing that you might have noticed in all the scatter plots, let me change the color, in all the scatter plots, setosa is linearly separable. The setosa is linearly separable. So over here I can separate it. It will not be 100% accurate. Over here also I can separate it. Not 100% accurate. Over here also not 100% accurate. Over here I can separate it with 100% accuracy. Over here I can separate it with 100% accuracy. Same goes here, 100% accurate, 100% accurate, 100% accurate, 100% accurate. This is also 100% accurate. Okay, so you can see that except these two, we can separate the setosa from other two with 100% accuracy. Okay, So now you can see that when we have sepal width and sepal length, and over here sepal length and sepal width, only on in those two cases it was not 100% accurate. Okay, other than that, when we have petal length, petal width, petal length and petal width, it was 100% accurate. Even though with petal length, if we take sepal length or sepal width, it still is 100% accurate. Same goes for petal width. And over here also you can see with petal length, if we have sepal width or sepal length, they still are 100% accurate. If we have petal width and take sepal length and sepal width with it, it is still 100% accurate. Okay, so what I am trying to say is that we can easily conclude that petal length and petal width are more important features then sepal length and sepal width, then sepal length and sepal width. Okay, so we can conclude this easily from this graph. Okay, because wherever we have petal length and petal width, the accuracy of separating centosa from others automatically becomes 100%. Okay, so this proves that petal length and petal width are more important features than sepal length and sepal width. So the another conclusion is that setosa is linearly separable. Okay, so you can see that in almost all the in not almost, in absolutely all the graphs. Okay, that setosa is linearly separable from the other two species, and the virginica and versicolor, virginica and versicolor have overlap. Okay, so this was the analysis of pair plot. So by now you would understand that 1D analysis, 2D analysis, 3D analysis and pair plot, these two conclusions are always same. Okay, so what I mean is that if we are doing 2D analysis and then again doing 3D analysis, so that is not very much helpful. It might help in some cases but not in maximum cases. So what would be a better solution is directly go to pair plot. Over here you can easily get the 2D analysis of all the features, and we can simply derive the conclusions from here. Okay, so this is when we are doing the scatter plot analysis. Now this pair plot also has some limitations. Okay, so now suppose if the number of features are 10, if I have 10 features, then the pair plot is gonna be 10 into 10 of 100 graphs. Okay, so if we have 100 graphs, it will become very difficult for us to come to a conclusion, because we will have to look through 100 graphs, and it will get very confusing at a point. Okay, so to overcome that, what we do is we apply dimensionality reduction techniques. Okay, that is the majorly used ones are PCA and TSNE. Okay, others are also there, like random forest algorithm and like truncated SVD, kernel PCA, but these two are majorly used. So what these two do is that it will reduce the number of dimensions. It will reduce the number of dimensions from 10 to a significant 2 or 3, and then after that we can perform our normal exploratory data analysis. Okay, so this is one limitation, and this is how we overcome it. Okay, so this was all about pair plots. So see you in the next video. Thank you.